Most of us know the story of how Isaac Newton first became interested in gravity. An apple, falling from a tree, hit him in the head. But what did Isaac Newton end up discovering? And how have our understandings of gravity changed over the past couple centuries? The classical understanding of gravity that Newton came up with in the 17th century can be described by this equation. F is equal to g times m1 times m2 divided by r squared. In this equation, F is the force of gravity between two bodies whose masses are m1 and m2. And r is the distance separating them. This g is the gravitational constant, which Newton came up with through his experiments. This equation means that there is a gravitational pull between any two objects in the universe, no matter how far apart. However, this attraction only becomes noticeable with very large masses at relatively short distances. So it is true that you and a friend are attracted to each other through gravity, but this force of attraction is so minute that it's actually negligible in everyday life. In this case, it's about 1/10,000,000th of a Newton. To put that into perspective, that's about 5 million times less than the amount of force it takes me to throw this football. But when it comes to the scale of celestial bodies, such as between the Earth and the Moon, the force of gravity can get much, much bigger. So this explains what gravity does, and it gives us a way to quantify its attractive force. But our classical understanding of a force is that something must be pushed or pulled. So how does gravity work if neither of the objects can ever come into contact with each other? This question was left unanswered for centuries, until in 1915, Einstein came up with his general theory of relativity, which, in simplified terms, explains that the bending of space-time actually causes gravity. Here, I have a two-dimensional representation of space. You'll notice when I put a massive object in it, it actually bends the fabric. This is analogous to how things like red giant stars bend the fabric of the universe. This bending causes the attraction of gravity, which allows things to orbit around them. This space model can actually show us how two objects attract each other as well. For example, here we have M1, here we have M2, and as you can see, they're both bending the fabric of the universe to their own degree, which causes their attraction. This phenomenon was summed up nicely in 1973 by John Wheeler when he quoted, "Space tells matter how to move, matter tells space how to curve."